This continues the videos on NIM. I just wanted to show one more NIM game, which is a little bit bigger, with 4 groups and the groups going past 16, as opposed to just 3 groups and not even going past 8. But it's the same illustration of the strategy. So here we start with 6, a 7, a 13, and a 19. And I've gone ahead and put on the binary number glasses and visualized this as a 4 and a 2. This is a 4, a 2, and a 1. This is an 8, a 4, and a 1. This is a 16, a 2, and a 1. In binary, the numbers are like this: 110, 111, 1101, and 10011. And that's the starting position, so it's player 1's turn to move. This is what player 1 has to deal with. That's what the 1 is for. And the goal for player 1 is to put it into the bad set of positions, the set of positions where all the column sums here are even. Or in other words, where if you visualize it with these special glasses on, where you can group things magically into powers of 2, that it looks symmetrical, that everything pairs up. And how do you do that? Well, let's look at the first digit, the highest digit where it's not paired up. Okay, the 16's digit here, 2 to the 4th. 16's digit is not paired up. So we got to change that, and there's no way to do that by subtracting other than to destroy that guy and change it to a 0. But, as I've said before, that gives us a whole lot of sticks to play with. We've essentially taken out 16, but we don't have to take out all 16. We can take all but one of those, if necessary, or any number less than 16, and use them to flip these digits if that's necessary as well. Well, this one also was bad. The 8's digit was bad, so we're going to have to flip that. So we take out the 16 and we put back in an 8 right here. Let's see this. Oh, the 4's digit was bad. It had 3 4's. Those didn't match up, so we're going to put in a 4. But the 2's digit was okay, so we don't need to mess with that. And the 1's digit, actually, we had an extra, and we want to take that away. So we're taking away the 16 and the 1, so that's taking out 17, but we're putting in an 8 and a 4, and so that puts back in oh, actually, no, I'm sorry. The 2's digit was bad too. So actually, we're taking away the 2's digit and the 1 digit, and basically taking everything away, this whole 19, and putting back in these digits to fix it. So that's it creates 12 for this guy. Let's see if that visualizes right. We've got the 8 and the 8 paired. We've got 1, 2, 3, 4 groups of 4. That's an even number. That's symmetrical, so that's good. We've got these 2 were already paired, and we haven't actually messed with that. We just took out the 2 that wasn't paired. And then these ones were paired as well. So basically, we took out this 16 group that didn't have a partner, and we took out the 1, which was an extra. We took out the 2, which was an extra, and then we gave partners for the 8 and the 4 here in the 13. Okay, so that's what player 2 has to deal with. That's a symmetric position in the sense of when you wear the glasses, these power of 2 glasses. Or in other words, it's an even column sum of each column in binary. And that means player 2 is not happy. But player 2 wants to do something, so they go ahead and they take a bunch away from this pile. They take that down to 3, let's say. Well, how does player 1 deal with that? So now the column sum in the 8's digit is messed up. That's odd. And the column sum in the 4's digit is messed up. And we just want to, and the 2's digit actually, but not the 1's. So we just want to correct that. Okay. So we definitely take away the 8 in the 12. So that's gone. And then we just redistribute. We say, oh, do I want to put back any of that, or do we want to actually take more away? Well, the 4's, these are a pair, but she took away some of the 4 here that was in the 13, so we don't want that to go away too. So once again, we actually don't want either of these to stay. These are going to go away, so these 2 zeros are indicating that. But we do need to put back in a 2 because, oh, I should have separated this out. Because now she put in an extra 2 here that wasn't there, and we gotta find a partner for that. Well, there's plenty of sticks to do that. So we take away the 8 and the 4, we put back in a 2. That amounts to subtracting 10 and making it a 2 pile. Now player 2 is still trying to win. So player 2 has got this to deal with, and let's say she just takes away all the 3 pile. So now the 4's are still good. They still match up. Now, but there's an odd number of 2's and an odd number of 1's. That's pretty easy to deal with. I just take this 2 and I change it into a 1. I have to say, sometimes there's more than one correct move for this winning strategy, but here I just take this 2 and move. That's a simple move to change that into a 1. Now they're paired up again. The 4 and the 2, the 4 and the 2, the 1 and the 1. Now let's say player 2 tries to take away this 2 and this 1. Okay. Well, now the 4s are still paired up. The 2 is alone and the 1 is alone. Okay, so I just change that 2 to a 1. And that removes the unpaired 2 and pairs up the 1s again. So that was player 1's move. This is what player 2 has to deal with. 4-1, 4-1. Whatever player 2 does, they're not in a good position. Maybe they take 1 away from here. Okay, so now it's a 4 that's unpaired. 3 1s, that's bad. And a 2, oh, it's all unpaired. Okay, so how do we deal with that? That's probably the hardest situation. But player 1 can deal with that. We need to remove the 4. So that's certainly going to reduce this, but we definitely need to work on this pile. It definitely chooses the pile to be worked with. We got to remove the 4, and then we've got to put in a 2 for a pair for this, and we've also got to remove that 1 because it was an extra. So these 1s are happily paired, so get rid of the 1, get rid of the 4, but then use that to create a 2. So you get 2, 3, 1, and from there the end game for that is quite easy to see how player 2 is very unhappy because they're definitely going to lose.